this is our agenda for today. We'll say a couple of words about the project. Then we'll revisit some of the performance and benchmark and tuning rather briefly, because some of you may have seen these before. Then we'll address some of the more important configuration stuff, like policy banks and lookups. I was hoping I could talk about DKIM setups and things like that, but it's rather well documented and probably won't fit in this time slot. So if you're interested in other areas that won't be covered here, just contact me later and we can discuss it. And then what we have learned here we'll put to some practical use. And at the end, visit our latest edition with the last version of Amavisd that was published a week ago, 264, which brought some new and exciting monitoring stuff. Okay, so what it is an interface between mailer and virus checkers and or spam checkers. We're talking about plural here. It used to be only Spam Assassin. Now with the later versions, there can be other spam checkers as well. Checks for banned contents, checks mail headers. Some checks are built in, the other is delegated to external checkers. It does quarantining if needed, does DKIM signing and verification, and of course there are a lot of monitoring hooks. We'll come to that later. Why is it popular? Because I tried to make it very reliable and easy to test and to debug tool. So it checks every status of every operation, which isn't something that all open source software does. People are lazy, don't bother checking. But I do care. Failures are non-fatal. Mail is not lost. Adheres to standard very carefully. I read RFCs and I implemented as it should be. It's reasonably fast considering it's a Perl program, but it does the job quite well. Security is one thing that I keep on mind all the time. It's good that the fact that it is written in Perl brings some good benefits. There are a few possibilities for loose pointers, for stack overruns, and Perl does taint checking, and it can be run in a chroot environment. It's rather mature product. It's been 7 years under development, and it is open source. Okay, here a couple of words about history. It all started, is it 9 years ago, when people realized that the Windows problem affects Unix people as well, and part of the problem can be solved there as well. And a couple of people made shell scripts, and one to remember is Christian Ricard, who registered the domain Amavisd.org, which is still registered, and we'll come to that a bit later. Okay, this shell script evolved into a Perl program, which later became demonized faster. There was some attempt to redesign it in a modular way, but before this project finished, I started work on improving whatever we had here, and out of this, Amavisd-new was born. It was initially as a set of patches to the Amavisd snapshot, and later other remaining projects didn't evolve much, and Amavisd-new was steadily in development. So some of the milestones worth mentioning SQL lookups. Here's one controversial to some thing. It's a packaging thing. Everything is in one file, but it doesn't mean it is a monolithic program. It is a set of modules, but it is distributed and contained in a single file. So it is easy to install. Just put one file there, and it picks up whatever modules it needs and compiles these. Some LDAP lookups were contributed. We'll come to that later. Policy banks was invented. We'll come to that later. IP address formats, syntax processing, and lookups was added in 2004. That's the time we got our IPv6 connectivity at our institute, of course, and it had to reflect in my code. Monitoring program was developed, which is still in use today and quite useful tool. What we have here, content categories, pen pals is a way of associating a new mail with previously sent mail in the opposite direction, so that the responses to our previous mail are treated more favorably. New SMTP client was rewritten. Previously I used a Perl module which wasn't very actively maintained, and some bugs were standing there forever, so I just decided that it's about time to rewrite it. So it finally got support for pipelining, for IPv6 of course, and some other stuff. Worth mentioning, about that time I was invited to be spam assessing committer and later project management committee member. So this is a reason why my involvement in spam assessing took its place as well, and I will mention it from time to time later on in the presentation. About a year ago, we got domain keys identified mail support both for signing and for verification. It is based on the public module mail DKIM, which is quite well maintained, runs well. Here's the date. You may remember this motto when Mozilla was born. It was said it is spelled Netscape, but it's pronounced Mozilla. So I can say the same for Amavis. It's spelled Amavisd-new, D for demon. But in free talk, I usually say Amavis. And at this date, Christian Bricard, the owner of this domain, contacted all our previous contributors to the project, both to the Perl version, to the NG version, to the security people and some other. And it was collectively decided that the older projects are officially considered abandoned, stopped. No, they won't be developed anymore. So that Amavisd-new is the only surviving and actively being developed branch out of this. And the domain stays. What is yet to be done is to rewire website and things like that. Okay, the last three versions. Previous one got support for other spam checkers besides spam assassin. This one is quite popular, so also this one. And the last version, last week, got true SNMP agent So it allows you to do monitoring by SNMP clients. So it all gives 7 years, more than 7 years of active and steady development. And like Vitsa showed yesterday, his chart with number of the size of the code. In my case, this is the number of lines. And as the years go by, you can see it is rather steady development, and it grows about linearly. So it may bring some some questions. Did it grow too large? Some may consider it bloated. Well, as I mentioned before, only these modules that are actively used in the configuration are compiled and brought from that large container file. So there are several tools which are only run from a command line if necessary, like generating domain keys and testing keys, and all things is not burdening the running code during normal operation. And it is about the same size as a spam assassin. So I don't know. Is it large or isn't it? Or is it not? The critical code paths are well optimized. So this is one of my priorities besides good maintainability and security. So it should run quite well. And the main bottleneck, the main hog in all this is spam assassin calls. The rest is rather quick compared to spam checking. I collected some virtual sizes for various configurations. I tried to remove all modules, then gradually brought in one by one, and see what was the increment in the virtual size. And it starts, the Perl itself, just running an empty command consumes 4.5 megabytes. When you bring the base Amavisd-22, and then each of these modules adds some addition. For example, one of the larger ones is Berkeley, and DKIM is not as bad, but most of the size comes from OpenSSL library. So once you get that in, you have it for free for other modules in Spam Assassin. So it's shared code, which amounts to about 60 megabytes with baseline rules, with whatever comes with Spam Assassin 3.5, the original rules. But what is important on 32-bit platform, when you go to 64-bit platform, I was very surprised myself. I was expecting an increase, but I wasn't prepared for this, for the amount of it. It's more than twice the figures in the previous slide. So it amounts, okay, this is 200 megabytes. It's our production server with all the stuff, lots of additional rules brought in, several plugins additional. So I would say 150 or maybe or something about 100 megabytes it's something that is to be expected. So this is something to keep in mind. It probably doesn't pay off to have 64-bit platform operating system when you intend to run Amavis with Spam Assassin. There is no obvious advantage in it, and just consumes more than twice the amount of memory. Now this is something I collected from my benchmarks on rather small machine, a small memory machine a couple of years ago. But the rough figures should about still be right. I pushed the setup so that by increasing the number of running processes, I was beginning to run out of real memory. Things got slowly paged out. And I was measuring performance all the time. So before things start getting slow, I'm referring to swapping and paging now. So when things are still running well, it's about 60% of memory that can be paged out without much effect. So it's not, paging is not bad as long as it doesn't occur all the time. Paging unused code is a good thing. So you don't just add up 200 megabytes times 50 processes is what we need. It's not necessary. You may do just well with half of it. And there is some shared memory in that. I mean, in addition to this 60%, which can be paged out, there is some of the remaining code that it is shared among processes. Okay, that's rough estimate. About 1 gigabyte for a minimal configuration runs about 20-25 processes. Okay, let's go to some benchmarking data rather briefly, but there's one important thing I would like to point out here, because the number of processes is the main tunable knob to Amavisd. As the number of as you run more parallel processes, you can run more messages per second. This is mail throughput, like messages per second or messages per hour, through your whole system. Of course, up to some saturation point, at which point the performance levels off. You add more processes, nothing happens. You gain nothing, and if you push it too far, things start swapping, paging, performance go to hell. So the idea is to stay here in this region. And where is this region depends very much on your hardware and on your configuration. So the idea is to find some spot before the curve levels off, and this is the sweet spot where we want to run our server at. This is 6. This is this is 5 years old machine. The data, but the shape of the figure still applies, is general. So I suggest when you try to set up new server, is to push it by and see how it behaves, and then stay at that limit. Okay, this is something, of course, that can be expected. This is raw postfix, no special, no content filtering, no nothing. It runs about that many messages per second, and the number of processes is irrelevant because we're not running any content filters. Now, the usual setup for Amavisd is to run it in between, sandwiched in between two parts of the mailer, or between two mailers. So mail comes from to the first part of the mailer, then goes to content filter, goes back to mailer, and goes out. So each mail hits the mailer twice. So if you set up this configuration, postfix talking to itself, but passing each mail twice to the system, of course, automatically the performance drops to about half. And adding to that, Amavisd, without any additional processing, drops that to about quarter. And adding virus checking is not too bad. So, okay, this is something we have to live with it, but just want to give you the rough idea. And yes.
If you go to the previous slide, this is really a worst case, because the link between the remote client and your first postfix is much slower than the link between postfix and Amavisd.
Mm-hmm.
And so the time spent in transit of email from way distant, far away.
Yes, yes. This is benchmark data. It was.
This is as if all your clients are sitting back in front of your mail server.
Yeah. This was. This. Yes, of course.
So you have a very fast local path and a much slower external path. So it's not as bad.
It's not as bad as it looks. Okay. Now, having virus checks only, it's acceptable, but add to it spam checking, things get considerably slower. And if you are unfortunate enough and run a command line virus checker, you are down there. Okay, I won't go into details, just want to say that the actual curve shape depends very much on your configuration, what plugins you run, what host what are the capabilities of the host running it. So each site gets a different figure. Perhaps worth mentioning is that Pfizer plugin is one of the heaviest on the CPU. So if you can drop it, the performance goes noticeably up. That's the same thing. So the main tuning knob is the number of processors. Avoid slow command line virus checking, and the rest is rather the usual sysadmin stuff, like running separate disks for MTA spool directory and for Amavisd temporary. In Linux, it used to be necessary to disable syncing on logs. I don't think this is still true for the newer versions by default. Some rule sets can be expensive. I learned that firsthand, like the rules emporium. Some rules from the rules emporium can be expensive. And if you keep large quarantine on file system, it pays off to build one level of subdirectories so that not all the stuff gets into the same directory. And pushing this further on, you can separate MTA and Amavisd and put them each on a different host. And of course, you can have several mailers, each with its MX record and so on. Now, to the configuration. We'll just say some general words. We'll talk about a couple of rather important topics for me, at least. the concept of where mail is coming from or where mail is going to. Some hints on logging, on syslog configuration. We'll mention how to specify where mail comes in and where it goes out, and some other variant of it. We'll touch policy banks, lookups, content categories. Okay, the file to start with is this one. It's in the distribution. It contains all the configuration variables. All of them are listed there, at least listed, and their default values are also documented there. So it is also organized in a rather systematic way, much better than the other file. There is one sample file which is rather old and disorganized, so don't look at it. Just start with this one, and you get groups of configuration variables that fit together. So on the general stuff, you do where are directories, what is your host name, under which user ID you're running, the source, destination addresses. The important knob here, as we mentioned, is the number of server processes you want to run. And here's one suggestion. I don't think it is a default. Set it to 2. It doesn't cost much, but it gives you much more useful output from Amavisd-new. We'll come to it later. Just the configuration, the configuration variable gets mentioned here. Now about mail flow direction. There are several components within Amavis that need to know where mail is coming from, or they need to know where mail is going to. It's similar with postfix. You know mail is coming from my networks, or is it authenticated, or is it not, and you know where it is, where the recipient is. Is it yours or is it outside? So this is one thing to prevent having to prevent running an open relay. So you have to know where, if the mail is originating from your own users, and whether it is going to outside or going to internal users. So this is a chart which I like to show every now and then. There are two bits here. One says mail is originating from our site, from our users. That either means authenticated users or internal networks. And the other information point is where mail is going to, the domain of the recipient. And as you know, each message can have multiple recipients. So this applies to each recipient separately. For example, mail can be both outgoing and internal to internal at the same time when it has more than one recipient. So if it is not coming from internal networks, that means it is coming from outside, and it is going to outside. This can't happen. Nowadays it can't happen. It used to happen 20 years ago when people didn't care about it. But the other three cases are common. Mail is inbound if it has local recipient and it is coming from outside. Mail is outbound if it is coming from inside and it is not going to local recipients. And it is internal to internal when both applies. And here are the main configuration variables, configuration settings, which determine or which tell to Amavis what is the direction of the mail flow. The list of my networks, or the flag originating, we'll come to it later, tells when this is set, or when IP address falls into this range, we know that mail is coming from internal networks, from our users. Could be authenticated roaming users. Needn't be it needn't be inside the our own network address space. And the destination is determined by a list of all your local domains. Now, this in more detail. Destination, as I said, is determined by the list of all your local domains. And speaking of postfix, that means all these address classes. Don't forget local domains, virtual aliases, virtual mailbox, relay. All of these are your own domains. They need to be listed in order for things to work correctly. Things may work most of the time, even when this is not configured correctly, but sooner or later you will hit to one or the other thing that does the wrong thing. So do not wait for bad thing to happen. Configure this correctly, please. And it affects the following things, like inserting some mail header fields which are interested for our own users but shouldn't be disclosed to external recipients, like adding address extensions, the plus addressing, which is one way to redirect incoming mail to a dedicated user's mailbox, for example, spam mailbox, virus mailbox, whatever, if you want it. Recipient notification, pen pass, mentioned before, won't go into detail. Defanging, you don't want to modify suspicious mail on its way out. You only want to do it on the way in. Now the other part, the origin, the source of the mail, is determined by these two settings. Actually, it is this variable, which is the only one in the more recent versions of Amavis that tells whether the mail is originating or not. It is the setting to maintain backwards compatibility. There is an automatic automatism which turns on originating when IP address falls into this range. So as far as the rest of the code is concerned, this is the only thing that tells whether mail is originating or not. It can be also set explicitly by a program hook, by user's code, external, or by policy bank. We'll come to it later. And these are some of the things that need to know if mail is coming from inside or not. One of the more important things is domain keys identified mail signing. You don't want to sign mail which is coming from foreign users. Some people want to insist on inserting disclaimers, and this also applies only to the mail originating from our users, locally submitted. Bounce killer. Perhaps I should should mention it. It's a feature I added a couple of months ago in one of the, I don't know, 2 versions ago. When our domain was abused in large scale for sending spam to innocent people, and we got a lot of backscatter. So there are some ways how to prevent it. There are some of the instructions are also in postfix documentation. But since I already had a SQL log of all the mail traffic, I said, why not look into the received bounce and see if it refers to a message that was truly originated previously from our site. And if we can tell that it definitely is not, then we can simply throw it away. So this evolved through about 2 versions. It's amazing how many sites or how many mailers produce non-standard bounces, non-delivery notifications. It's a hard task to. It's easy to parse the standard form. It's hard to do it for at least for the most of the remaining rather popular ones like Qmail. Okay, I won't go into details. So there people are very inventive how silly bounces they can produce. Okay. This is what I already said. This flag is the only thing important. It is either turned on implicitly by IP matching MAN networks or explicitly. For example, here's an example how to do it through a policy bank. You say, I have here a policy bank which is arbitrarily named originating. All it does is turn on this flag. And now how to associate it with a TCP port number, you say on the interface on the port on this port number you activate this policy bank and you let Amavisd listen on this additional port number. And on the other side of the story is, for example, tell postfix to send all locally submitted mail to this content filter. This is it. This is one way to do it, not the only way. Just a quick mention, spam assassin needs to know the same thing. Needs to know where mail is coming from, where mail is going to, and it is unfortunate enough that all the data it can see is the mail header, so it has to parse received header fields and match these addresses against these 3 lists. So when you're doing the configuration for Amavisd, don't forget to do the same for spam assassin. It tells which IP address is the one to match against RBRs, for example. Okay, now to logging. Just some detail which I find rather useful, and Amavisd traditionally used log level for its messages, ranging from 0, which is the most important, to higher numbers, which is rather debugging. Later on, it was extended on the other side with more serious fatal errors, just a couple of them. And Spam Assassin also has its own concept of how serious some logged report is. And these priorities are mapped into postfix, into Amavisd log levels, like this. And when the log entry is sent to syslog, it is mapped to syslog priorities. So, okay, like this, for example, you say we will only produce log messages up to level 2 or maybe 3, or use 5 when you're in trouble. Turn on syslog, specify syslog facility, and in the syslog you are free to use its own configuration mechanism to do some interesting stuff. For example, I tend to keep all my long-term data, which is level 0, only the main log entries, one log entry for each message in this file. But I keep more verbose log at level 2, and at level 5 I keep everything at yet another file. But these two are throwaway. They are kept for 2 days. I can analyze if there is any problem in retrospect, and it needn't be kept. So when you're in trouble, when you need to turn on debug level, it's useful feature to write it to a separate file. You can then examine it and throw it away. Okay. Won't go into detail, but it is possible to configure what goes into the main log entry. It's a macro. It's rather obscure syntax, but it's a true macro processor. It can produce things like author address, subject, message ID, user agent, mail size, Spam Assassin score, list of Spam Assassin hits, which rules we're banning, domain keys ID. All things can be added to the main log entry, whatever you choose. Most of these are just commented out, so the sample code is already there. So just re-enable it and you have it. Okay. This is the input side of Amavisd daemon. It can listen on SMTP or LMTP protocol, or an additional protocol which is loosely based on postfix's policy delegation protocol, which is used to interface with Milter, send mail Milter, or also postfix Milter, through a third-party program from Peter Rechor, I believe, which is rather good, but I'm not running it, so I can't tell very much about it, except that it does work, and it is much better than the historical one that is still in the package. The other usage for this protocol is to submit release requests from a quarantine. Amavisd can release mail, can re-enter mail into mail stream taken from quarantine, and using this protocol you can tell which mail to pick out from your SQL or file system based quarantine, and either send you directly to mailer on the output side, or to resubmit it to its input side and let it pass one more time through all content filtering. For example, if you screw some rules, spam checking, or if your virus checker suddenly starts declaring all mail as infected, you end up with a lot of messages in the quarantine, and you want to, after you fix the problem, you can resubmit all these messages again to the mail stream for repeated checking. Okay, this is a list of TCP port numbers where Amavis will listen to. This is some access control lists so that not everybody can connect to Amavis on these ports. You can also bind it to a specific interface, so not anybody on your Ethernet can would be allowed to connect. And apart from iNet socket, there's also Unix socket, which is mainly used to run this protocol on. But in principle, you could run SNMP on this interface as well, and also you can run this protocol on iNet sockets. Yes.
Are there any efforts on making the configuration easier for people who don't understand Perl?
No. I know it is a tough one. I know it is a problem, but
just there are some values divided by comma, some some enclosed in quotation marks.
Okay, I can mention a couple of these, and I have later, I believe, a couple of slides which also address Perl syntax. So we'll just briefly mention it, but of course the details are. The configuration file, as was mentioned, is a Perl program by itself. It is interpreted by Perl itself. It uses Perl syntax. It is not parsed by Amavis. It is run. It is executed by Perl. So typically you see assignments to scalar variables. In this case, assignment is a reference to a list of numbers. This one variable, the @ means it is a list, unlike the $, which means it is a scalar. So this is a list. It gets a list, and this QW operator is just shorthand for Perl, which takes its argument as a string, splits it on words on white space, and you end up with 3 strings, with a list of 3 strings. So just a shorthand. Okay, this is an example of a string, single or double quotes. Double quotes allow some evaluation of other variables, like you have to quote or to be careful when you use a $, or @ within double quotes, but single quotes are more are easier to understand because there's almost nothing, almost anything you put in there ends up in the resulting string. Okay, this is the output side. So this tells Amavis where it should send its mail to. It's checked mail to. In this case, I've listed only 2 variables, but there is also a setting to tell where to send quarantine messages, where to requeue to, but the principle is all the same. So you say forward method applies to mail that it is passed, that is checked, it is fine, it should be delivered to user. There's a protocol, there's the IP address, and tells the port number on the mailer which should accept this message. This is the same thing, except that it controls delivery status notifications and some other administrator notifications. Instead of using a fixed IP address, you can use asterisk, which means go back to the same IP address the request came from. And instead of the port number, you can also use asterisk, which is just a shorthand to say use the same port number as on the input side +1. So just a convention.
Yeah.
Yes?
You give the impression that this Amavisd-new could be used, and it's also in your documentation, could be used as a filter. Just you accept the mail and then filter it. That gives, in case you then do bounces, gives of course backscatter,
yes.
Which is not known to every user. So I see a lot of backscatter coming from Amavisd, badly configured Amavisd. Why at all is it still documented that way, and why at all do you still recommend using it that way?
The defaults have changed a couple of years ago, I don't know, 2 years ago. So by default, okay, I should start like this. Even if you allow Amavisd to do bounces instead of drop the undesired mail, there are some fuses which prevent or limit backscatter. For example, if we know the message contains a virus, it automatically inhibits sending a bounce, unless you configure it otherwise. You can, for example, say, I know this is, I don't know, Word, Microsoft Word virus, which doesn't fake the sender address, so it is safe to send backscatter because I know it's coming from legitimate user. But this is very rare situation, so you probably even if you say bounce for viruses, it never happens unless you try hard to circumvent it. For spam, it is there's another fuse. It says if spam score is anything above this level, suppress the bounce. Don't send the bounce. And I admit this is one of the configuration variables that people often set too high, or there are some corner cases just above the level of spam where there may be when several false positives can happen. So in a limited way, it is acceptable to send bounces, especially if you know, for example, by domain keys, signed mail, or some other criteria, that the sender is a valid one. There are mechanisms to that, but I do agree that perhaps it should be turned off by default and not made so easy for people to enable it. And on the banned content side, it is similar. There are fuses. But it is rather unusual for example, if someone sends you a zip file or whatever, which is not a virus, but it does contain executable, it is quite likely that the sender address is valid. So it may be acceptable to send non-delivery notification, especially for internal users. If you know the mail is coming from inside, it's quite quite likely the sender is legitimate, so bounce would be acceptable in this case. Okay, the mailter is someone special in that the forwarding is done by the mailer itself, so just disable the forwarding method. And on the input side, you have to tell it not to use SMTP protocol, which is a default, but you have to use that special protocol. Okay, now going to policy banks. There's a set of configuration variables which are global variables which apply to all the processing. But there are also several possible replacement sets or groups of configuration variables. You can imagine a tray of ready-made replacement settings ready to be loaded on an instant notice. It would affect the message as a whole. These are not per recipient settings. When a policy bank, when these replacement variables are loaded, it affects the message as a whole. Now, for example, here's an example. You have a set of currently valid assignments, variables. These are variables, some scalars. This one contains a string, this one a number, this one is undefined, this one is a list, whatever it is. And then we have 3 policy banks, 3 trays of replacement settings. And for example, let's activate the blue one. It gets loaded, and whatever it brought, it is now in the current configuration. What is important is that it happens very quickly. It's a cheap operation, doesn't cost much. And then you get a green one, it applies, it's green. You get a red one, it applies, it unloads all its red ones, and this is the current settings that apply to the remaining processing. Now back to the Perl syntax. Here is an unfortunate difference or complication, because for normal settings you have this variable, assignment, replacement value, and the semicolon separates statements. And in this case you have a list, assignment, parenthesis, list. Okay, and this is a hash, which is an associative array. This is the Perl syntax, the key and its value, a new key and the value. Within a policy bank, because the policy bank is implemented as a hash, the syntax is slightly different. You don't have an assignment, you have this operator. You don't separate statements with semicolons, but separate key value pairs by commas. And lists instead of lists, one has to use list reference. And in syntax, this means that instead of parentheses, you use brackets, and instead of, and in the case of a hash, you use braces. Okay, here just an example to give you an impression. Is the policy bank named whatever it is. It replaces these settings. That's the name of the global variable, the replacement value. Same for this one, won't go into detail. It's another example, more sophisticated. For example, it raises log level, it tells mail is originating, it replaces the output address, so when this policy bank is activated, mail goes to somewhere else. Whatever. Spam destiny, let all spam pass through, and here's a replacement kill level, for example. How it is activated? It can be, policy bank can be activated based on the TCP port number. So this is the way how to do it. You assign to each TCP port number a name, one name of a policy bank to be loaded. It can be loaded by client's IP address. Here's a syntax to do it. I won't go into details. It's a list of okay, that's a good example for your case here. A list of IP addresses or address ranges. I've used both syntax just for diversity and as an illustration. This is actually a list of strings, comma separated, and this is a Perl shorthand, uses QW operator, which splits this string on white space and makes a list of strings out of it. So it's the same thing. Both these are the same thing. Policy bank can be implicitly loaded by having address match the list of your own networks. This is a rather new feature, new addition. It can load a policy bank based on the valid DKIM signature, which is quite handy tool because you can treat, for example, mail which is reliably coming from eBay or wherever, Technische Universität Graz, and give it some other treatment like whitelisting, not necessarily only for spam, also whitelisting for banned contents, for viruses if you like, for whatever. You apply different rules. Anything can happen, or redirect mail to some other backend mailer, whatever you want. There are custom hooks. It's just a way to apply your own Perl code, which gets activated at a couple of control points, and that code, your own code, can load policy bank as well. On the postfix side, the trick to use is let content filter go to different TCP ports for different sources of mail, if you like. For example, on a submission port, you can say, instead of the global content filter, you say feed it to this dedicated port. So there can be a policy bank waiting there and apply originating or whatever rules you want. And you will know that mail coming to this TCP port number is the one that postfix got on its submission port. Apart from changing content filter either globally or as an option in master CFI, master configuration file, you can also use the filter in restrictions files, which is just a way to, which is the same thing. Whatever is here overrides whatever was previously set in a content filter variable. Okay, lookup tables. We said policy banks are applied to a message as a whole. Lookup tables is a mechanism which is much older in Amavis, but it works on per recipient basis. But before we go to that, there are a couple of types of lookup tables. It's either associative array or list of regular expressions, or plain constant. And in addition to that, there is an implied lookup table when you enable SQL or LDAP. We'll go briefly through that, because this is old stuff. Associative array gives to each string typically a domain name or recipient email address, gives some values. It is unordered, and the search needs to run in a predefined search order so that it can get predictable results. And it can provide any value, not just in this case they are booleans, but could be any string. Any value could be obtained from a lookup on a hash. A hash is just a Perl name for associative array. This one is more plain. It's a simple list. Search goes, this again illustration of the same of two ways of using the syntax. It runs through the list. Sequentially, the first batch wins, and if it has an exclamation before it returns false. Otherwise, it returns end. If nothing matches, falls through, you get a false at the end. Regular expression, it's a list, but this time not plain strings, but regular expressions, and it can also provide any value as a result. And there is the last one, which is not really a lookup table, but behaves as one. It gives the same result regardless of the search key. The SQL typically uses two tables, but it is all configurable. What Amavis cares for is only to run some user configurable select clause, which should return some values, and whatever schema is used below, it is up to a site administrator. Now, in the past, there used to be hard-coded in code. It did first lookup for hashes, then for lists, then for regular expressions, and you had a bunch of separate names, separate configuration variables for each of these, and this, as the number of configuration variables grew, this grew out of hand slowly, and instead what was invented was a list of lookup tables. It's typically named with something underscore maps at the end. What it is, for example, this list of lookup tables consists of 3 lookup tables. One is a reference to a hash table, to a hash lookup, a reference to a plain list, a reference to a list of regular expressions. What it matters now that the code itself never now in the later versions never now consult these individual alt variables. Everything goes through maps variables. So if you change maps, you may just avoid consulting these alt variables. So you can say, instead of referring to these old configuration variables, you can put directly your lookup tables in here. You can read it from a file. Just an example. So to conclude this on policy banks, it affects a message as a whole. It's a quick and lookups serve to implement per recipient settings. And not to forget, lists of lookup tables can also be a member of policy bank. So you can replace the whole list with a new one on loading of a policy bank. Okay. Content categories is also one of the later additions. The main idea was to simplify internal code. It simply grew out of hand with having explicitly do something for viruses and then do something for band and something for bad headers and something for spam and something for oversize. So instead of just adding new and new and new variables for each type, like spam lovers, virus lovers, band lovers, oversized mail lovers, and so on, it just left whatever was there from the old times for compatibility, but introduced a more general concept, which is content category. So these are just names. Actually, these are names of plain integers. This is 9, 8, 7, 6, and so on. So this is just enumeration. And how it works. You run all the tests on a mail, spam checks, virus checks, header checks, whatever, and each test puts a flag into this, whatever you can say, bitmask or whatever, content category. For example, it can say a message is a virus. It is also spam because it has a score below the kill level. It is also spammy because it has score below the above the tag 2 level. It is also, some may consider it clean, although this is questionable, but okay. All these bits are set, and these are ordered by priority. So when you ask, what is the main content category of this message, you take the topmost from this list. In this case, it is virus. You say, this mail is virus, is infected. It is also spam. It also has a bad header, but it's not important. It has lower priority. And some recipients want to receive, for example, infected mail or banned mail or spam or whatever, and they can set through lovers lookup tables. They can say, I want to accept all viruses. So if you mask these two fields, and you ask what happens to the mail to this recipient, which is a virus lover, you search this list for the next one, ignoring the lovers, ignoring these bits. So the next one is spam. So for this user who doesn't care about viruses, this mail is treated as spam. That means he gets all the handling for spam, quarantining, notifications, whatever, logging. Okay, here's an example of the new configuration variables. They're identified by this end in their name. It's a hash. It's a Perl hash. It says for each category what happens. For example, for virus, insert this string into subject. For band, insert this string into subject. For spam, don't do anything. For spammy, use the old backward compatible setting. It's just an example. But what is important? Previously, you had, for example, three variables for this, but all remaining was not configurable. You couldn't say for band content you want this string added to subject, it was not possible because there was no setting for it. And instead of adding a bunch of new configuration variables, you just use this general principle. Okay. How do mailer and Amavis, how do you put it together? It's like Lego blocks, everything fits together. It uses standard SMTP protocol as a standard connectors. You connect it whatever, however you want. You make up your system the way you want it. On the Postfix side, as we mentioned, the content filter is the main configuration setting, which can be applied globally or as a command option in master file, or as a filter in restrictions. Okay. On the Amavis, you control it through TCP port numbers. You can load policy banks through, and you control the output through forwarding method. So here is one rather complex example, but just as an illustration. Here are two parts of the same postfix. This one is the receiving end, this one is the backend end. Here is Amavis. Here is just for more complicated example is a mailing list manager. So before, okay, let's repeat what we learned. Where postfix sends its mail, it's configured through content filter. Where Amavis receives its mail, is configured through its interfaces and which can trigger policy banks. On its output side, it's forward method, again to postfix, which is another master entry. Okay, this is it. I'll skip this one. It's rather tricky and not useful to many people. Okay. Here's for an example how to tell postfix that for each IP address a mail can be sent to Amavis either through different transports or to different ports. I will skip this. We can come back later or offline. The same thing here. Okay, so for example, the regular mail comes from port 25, goes to Amavis, goes out. For originating mail, it comes on submission port. Postfix is configured to send mail to a dedicated TCP port on Amavis, where a policy bank gets loaded, and this way Amavis knows the mail is coming from our own users, either authenticated roaming or from internal networks. Here's a more complex example. Mail comes from wherever it comes, goes through filtering once, goes to postfix, go to mailing list manager, which is configured because we want domain keys identified mail signing, which is configured to resubmit its fan-out mail to a dedicated server to postfix, which again sends to a dedicated port to Amavis, where a policy bank turns on originating and it knows it should sign the mail. And at the same time, you can disable all other checks, virus checks, spam checks, because this mail we know has already been checked once on the way in to the mailing list manager. Okay, now to the monitoring part of the presentation. The Amavisd-new, the nanny is rather old story, but it is rather important, so I'll just mention it. It's a command line tool. It displays its output on the screen, on the terminal. It lists all processes of Amavisd running. For each process, it tells either it is idle, it doesn't do anything, or it tells the log ID of the message which is currently being processed, so which can correlate to the logged messages. Then it tells how long was in this state, like 4 seconds was running for this message, and I mean 5 seconds was idle in this case, 2 seconds was running for this message. This one just came in, it was accepting a new connection, it just started its counter. And then it follows by, like in this case 5 seconds, it is 5 letters, in this case 2 seconds, it's 2 letters. For each second it says what was it that it was doing. For example, it was generating, I don't know, unique ID, it was spam checking, and then it was sending mail back to mailer. In this case, it was running virus checking, then spam checking, and then we're still running. We don't know what will happen next. The help option lists all the letters, so you can read through that at your leisure. This is how it looks on a normal operation. You get a handful of processes that are doing something, a couple of processes that are idle. This is rather long, but maybe normal, depends what it is doing. It's doing spam checking. It took 2 seconds to do virus checking. It's running spam checking for 10 seconds now. So this gives a quick look into the health of the system, not into detail, just to see if everything is all right, if there are some idle processes or everything is busy. This is mostly idle system. They get all the dots. Now, here is an example what happens when the program crashes. It does happen, especially when some external code is pulled in, like some decoders or whatever, Berkeley database. The way how it works is each process registers its presence when it is born, and it unregisters it when it goes away. So when nanny notices that process is registered, but it doesn't exist anymore, it says process went away. Investigate. This is the last log ID that job was doing. You can do a grep on the debug and see what happened. Okay. If there are some long-running jobs, like this one took 2 hours stuck in something, it tries to terminate it first gently, then more heavily. Okay, this is the new toy that came with 2.6.4. Here are its components. These are Amavisd processes, child processes. There are 2 databases, Berkeley database files. Each process registers its presence to nanny database and unregisters when it is done with when it is going to terminate legitimately, and it also tells what it is doing. If you remember at the beginning, I said, say, let nanny configure to level 2. If you don't give the level 2, you just see if it is running or not what it is doing. If you give a level 2, you see what it is doing. The other database collects counters, statistics counters from these processes. And traditionally, there were two tools. This one we know, Amavisd-new, which looked into nanny database, reported whatever was there. And there was another tool, Amavisd-agent, which looked into the statistics database and produced some output. But new with version 2.6.4 is the Agent X. Agent X is a name of a protocol, SNMP, Simple Network Management Protocol, which connects to your existing SNMP daemon and exports a view on this data to SNMP. So with the latest version, you get a MIB file with a description of everything that is in there, and there is a lot of stuff in there. And your regular clients, SNMP network management clients, can collect data from this and produce beautiful graphs like this. Just some examples. All processes, all child processes is the green field. It should be all the same, unless something bad goes wrong. And this many of them are busy. It's rather idle system. That's more interesting. It says for how many seconds, how many processes are running for this many seconds. So you can see if there are any long-running strange cases there. That's another view on the same data. It's the old command line tool. It instead of producing chart, it produces figures on the screen. Okay. Mail sizes, number of mail coming from inside compared to all mail being processed, how many mail is spam banned viruses compared to all the main to all incoming mail, how many of the clean messages are coming at all or from inside. Just some illustrations. Perhaps this one is illustrative. It says it shows timing, how much time is spent in each part of the processing. So of course, not unexpectedly, most time is spent in spam checking. A little else, this yellow thin line is decoding. Virus checking is almost invisible. Okay. This is a quick view on the health of the system. Again, you see the number of errors and warnings in the log messages. So if it should be about 0 all the time. If something bad happens, you know you have to investigate what happened. And as a bonus, because it was easy to do, I added a couple of variables which collect the number of messages in postfix spool directories, which is it is supposed to be quicker than running the same thing on, for example, by running find command through through a shell script or whatever. But just, it was easy to do, and it produces interesting data. Of course, the timing is also visible in the logs. There is a breakdown of where this 1.5 seconds was spent mostly. We can see spam checking is taking the maximum, is taking most of it, but we don't know where in spam assassin this is spent, this time is spent. And if you use the version spam assassin 3.3, you get also breakdown on timing on spam assassin, which is a rather neat feature. In this case, it spends most time in running regular expression rules at priority 0. It spends 1.7 seconds doing razor lookup. It spends 1.2 seconds doing DCC lookup. Unlike timing report for Amavis, sometimes in this assay breakdown can overlap, because spam assassin does a couple of things in parallel, like sending out RBR queries and collecting them later. So these numbers do not necessarily add up to this total number. They are usually more, the sum is more than what is actually spent there. Now that we came to that we mentioned spam assassin, let me take the opportunity to announce that, speaking as a program management committee member of spam assassin, that today the 3.3.0 alpha was made publicly available. It is downloadable from this directory. It's also on the mailing list announcement. Just a quick mention on what is new. Rules are now separate from code in the distribution, so it means you have to download rules separately and use SA update to install them, or just if you have network connectivity, which is what most people would do, just run SA update, which would automatically fetch rules from the network and install them. DKIM plugin was reworked. It provides a neat feature which is author domain signing practices overrides. The thing is that few domains currently say that they do sign all their mail by DKIM, and that you should throw away anything that isn't signed, like, for example, like some banks or eBay or PayPal. If they would do that, you would more likely throw away some phishing mail which claims to be from PayPal, but it is not. This gives you a way to manually say, I know PayPal is signing all mail. I know I want to throw all mail which does not come with a valid signature to be treated as spam. Okay, cooperation with Amavis is better now that Amavis does DKIM verification. It can pass its results to Spam Assassin, so its plugin does not have to do the check again. It can reuse the same data. And not only that, it can, Amavisd can give, for large messages, only part of the mail truncated can be given to Spam Assassin, and this would not break the signature, which it would normally do because if its plugin would do its check on the source. The main keys was removed because the Kim plugin does it all for both. We mentioned the timing reports. This is one trick that was necessary, especially for FreeBSD systems, which run smaller stack when threading is enabled for some reason. And it would, there were a couple of reports, including happened at our site, that a spam assassin would crash on compiling rules. Actually, Perl would crash on exceeding stack size. And this is a workaround to compile rules in smaller chunks so it survives with smaller stack. It is compatible. It is in production, several sites. Please try it, use it. Okay, we'll skip this. That's it. That's it. Questions. Lunchtime.